In tonight's class, we're going to learn how to create an assembly inside Solidworks, all the way through detailing and assemblies with a bill of material, the whole 9 yards. We first start off with a project, and here we have one. We have something called a drill jig. It has multiple parts in it. In the last class, we assessed what the components were and what were purchased items. The purchased items are the fasteners and the nut. Okay, those are purchased items. The only three things that have to be made are the base down here, the L bracket over here, and I'll call it the center plate, or the U bracket, U item right here. Those are the three items that have to be made. So those were made, and we have those in a folder right here. Compliments of one of you. We'll just remain nameless for now. So here they all are, the base, the center plate, the end bracket, and the different machine screws. Now, just a reminder, a little bit of review. The machine screws came from a website by the name of McMaster-Carr. Pretty much every fastener you could think of can be found here. Fastenal is another site to go to, but this one has CAD drawings all the time on everything they have, so this is why I always go here. So remember, for fasteners, you go into the section for fasteners, screws and bolts, and then you have to assess what kind of fastener. For example, in the case of this item, it's a slotted head, flathead screw, so it's flathead. Okay, it's a slotted head, so that's a slotted flathead. Never thought there were so many different type of fasteners, right? It's a fascinating conversation. Anyways, I know it's not. But it's important. Flathead, metric. Why is it metric? Because it's an M12. Everything on here is metric, so we know that. So this is an M12 by 1.75, and it's 35 long. So an M12 is right here. Okay. Automatically, we see that it's 90 degrees, which means we're going to have a little problem with the item it wants to go into. That's your indicator that there's going to be a small issue. We had this conversation briefly before, but now it's recorded. 35 long, so we go down here and find out the lengths. There it is. There's 35. When you click on it, let me maximize this for a minute. You'll find out when you pick on the item, you see this in the upper left corner here, it says product detail. When you click on that, you have this pretty looking image right here on the left side. Then you have this very nice, complete, which I absolutely love, detailed list about the item in question. And then below that, you have a very nice detail drawing. And on top of that, you can download the model. That's the best part. And that, I think, is what you have done. So, in this case, this is the 91430A168. And if I look in our folder, we'll find out. Oh, you picked it with the wrong end, the wrong head. Okay? And that happens. You picked it with the socket head, so which requires an Allen wrench. So, and if you did do the wrong one, that's okay, because it is that straightforward. All you do is you're done with that one. In fact, we'll leave that in there just for the sake of showing how to swap it out, okay? So I'm not going to worry about it. We're going to leave that be. I'm going to, though, now that I know that the one that's in there is incorrect, I am going to download the correct one. 3D SolidWorks model, I'm going to hit save for this one. And eventually the little dialog box appears. There we go. I can say open with, and that's all right. Now, because it's native to SolidWorks, it literally opens it. And you get to see exactly how this fastener was made. It's beautiful. So this item, you can just do File and Save As. And just save it. I'll do Save As and save it in here. And you'll notice, remember what I said, McMaster-Carr is smart. They want you to download their part because then you'll have their part's model number. Okay, which means your tendency to want to buy it is there. Cool? It's a beautiful thing. So I'm going to hit save. Saving will convert into current. Yeah, that's fine. So we hit save and we're done with that. As far as the detail drawing of the item in question, we really don't care for the detail drawing because, don't say. Because the reality is we're not going to be the person creating the detail drawing. We're going to provide it with our paperwork, but I can't, there's no reason for me to literally take the drawing and generate a new detail drawing. So all I need to do there is take the 2D PDF and save that. See that? And let that be. Now I would save it wherever I'm saving my files, and then when I turn it in to whoever I need to give it, in your case you're giving it to me because I'm the client, you're providing with them no thanks. We're providing with them everything that they need to go ahead and seriously? Alright, save as. There we go. Sorry, I'm trying to say it while I'm doing it. You're providing the client with everything that you're going to supply with the job. Okay? And it's okay if you say that this is the vendor. 99% of the time, fasteners need to get replaced. So it's not a bad idea to tell your customer what the fastener information is. I would not consider that proprietary information. All right? Don't give them the CAD files of the product, you know, the assembly and the components, but this kind of stuff you can actually just give it to them. So getting back to this item, that's the correct item. Is the other item correct? The other one's correct? Okay. So I'll ignore that. So let's get back in here. Whoops. So once you have your files and you know where everything is, come on you. Hello. There we go. Then all you have to do is create something new. You know how to do detail drawings, so I don't need to talk about that. All you need is all we need to cover tonight is how to create an assembly, and then ultimately a detail drawing with a bill of material. So here we go. Once you have your files done, you're going to create something new. What does it want to create? It wants to create a new something. It's inches. Let's see. ANSI? Is this ANSI or is this ISO? Is this inches or is it metric? Yeah, millimeters. And it's ISO. That's our standards that we're going to use. We hit OK. All right. Now, parts are what you're used to making. Detail drawings are what you're used to making. Here it goes. You're going to do the one in the middle. Assembly drawings. This will be the first time you do it. Parts you've made, detail drawings you've made. Here it goes. When you make an assembly or a part file, they both can be in a detail drawing. Get it? Okay, that's what you're going to find out next. Right now, let's go into assembly and hit OK. And now, the first thing it wants to do is, hey, what parts you want to bring in? It knows the folder I've been in, so I can bring that. All I got to do is literally pick everything. Okay, I can do it in one shot. And I hold my shift key down, right? I click on the first item, hold my shift key down, pick the last item, picked everything. Or, if you want to take the painful route, one at a time, you can insert them. That's not my way. I'm too lazy for that. So I'm going to pick the first item, hold my control key down, pick the last item. You guys want to stop me, right? Because you're going to say I'm going to bring in an extra fastener that I don't need, right? And I'm going to say, that's okay. Let's just look at it anyways. It's all right. We're going to hit open, and boom. It's going to drop them all in there. And here's how it does it. Whatever was in there, you just keep clicking, and it keeps dropping them. One at a time. Done. That's it. Okay? So it brought them all in. I'm going to maximize this so you can see that. See, that's all it does. It just brings them all in. The first part that's brought in has a little F in parentheses. The F here stands for fix because that's the part that will not move no matter what you do to it. Why? Because that's what Solidworks does. The first part that you bring into an assembly, it fixes, meaning it locks it in place. Did you hear that? It will not move. Everything else is wiggly squiggly. I know, very scientific. Sorry about that. Recorded for life. Everything else moves. The first item that was brought in won't move. Let me just drag it. Come on, you gotta pull on it from a. Oh, that might be the first item. Let's see if this one. Yep, that'll move. The one that won't move. See that one? And if you want to find it really fast, instead of doing what I did, which is go and wiggle each one of them, just click on it in the model tree and it'll show you which one it is. Okay? The one that changes color, now granted, we've had this conversation before. Solidworks is not colorblind friendly. Sorry about that. It's not blaringly obvious which one got selected. But as you click on them, you see how they change color if the objects are bigger? Watch, see? The one that's blue is the one I clicked on. This one's tougher to see because it's a small part. The one that is blue is the one that's selected. The ones that are gray are not selected. You see that? Can you see that now? It's a little tough. You could always rearrange the colors on your computer so that they work a little more friendly with you, but right now this is default the way out of the box SolidWorks works. The first one's a fastener. Obviously we don't want that one to be fixed and we don't want it to define where everything has to go, so we unfix it. So you click on it once, and I know the word starts with the same letter, which is annoying. Float. Pick the other F word. So you float it. Click on it, right mouse button, or you fix it. Get it? Now I know fix to most of us in the room who've ever fixed anything doesn't mean fix. We're thinking we're going to actually correct something. But in this software, fix means that it doesn't move. And float means that it will move. Your choice of using the same letter as the beginning, choosing words of this nature, that's them. I'm just teaching you how to work the product. All right? So float and fix are the two words you want to know. If there's an item you must lock down that you don't want it to go anywhere, you fix it. Okay? Let's say the part I want to lock down is this one. I'm just being random. All right, guys? I'm just being random. I'm just going to pick this right mouse button. I want to fix that. This will not move. All of the rest will move. And then the nice part is it'll move to that without any issue. Then you can float it. Now, this is how I suggest you actually lock things down. This is my personal approach to Assembly 101. First thing you want to do is turn on your planes for the assembly, meaning the planes that belong to the assembly. When you turn on the planes in an assembly, the first thing you notice is even though they show that they're visible, they're not visible. The default setting is to not display planes. Okay? That's the default setting. So you have to go into hide and show, which is under view, and actually pick planes for visibility. And it will show all the planes. It's not selective. All right? Just appreciate that reality. It is what it is. Okay? Now, if I go to ISO mode, and just go to isometric, now we get to see where everything is. The master plane is this one. Let me drag everything out of the way. This guy. My personal approach is that I make everything, or I make my parent part, whatever is going to be my control features. I know it's a quality control term, but the thing that defines where everything goes. Like, for example, a car. You wouldn't pick the tire as everything gets attached to the tire, right? You'd pick the chassis, correct? When you think about what am I going to put everything on, the chassis. So that's what I mean. Whatever the primary element is going to be that everything goes onto, that's the item I want to lock in to the master plane. That's the way that I look at things. You're welcome to look at them any way you want. It's just what I do. So in this case, that's this guy right here. The base, everything goes onto the base. It's like the bottom of the bread of a sandwich. You put the bread down, and you put everything in the sandwich, and you put the next bread, the other slice on top, right? So that's what we're doing. We're putting down the base first. In this case, it is called base. So that's okay. That's not a bad thing. So here's the base. The base, this particular base is built, the way that it was built was off the corner, which is fine. There's nothing wrong with that. So I can easily constrain it in relationship to that. There's nothing wrong with that. As long as I like it to be as close as it can be to this plane. So the way I'm going to do it, the term used in SolidWorks is called mate. It looks like a paper clip. Okay, that's the icon for mate. Mate is the term they use for connecting different model parts, different parts to each other. They use the term mate. So in an assembly, that's what they do. So in my case, I'm going to be a little weird. I'm going to pick, of all things, the center of my helix. Let's see if this works. And do I have an axle plane to go off of? No, I don't have an origin. Oh, there's the origin. There we go. So I attached it, but the question is, did it attach to the center? No, it attached to the side of it. Does it matter? Not really, but I don't want it attached in such an odd manner. So I would recommend, what do you guys want? The back wall, front wall, you tell me. Let's do the back wall? Yeah, for fun. All right, so we're going to go to mate. We're going to pick, let's go back to isometric so we make sure we have our orientation correct. This is the orientation. We're going to pick this back wall, and then we're going to orbit about, and then pick this back wall, whoop, and it attaches to it. Okay? See how it moved to the plane? Okay? And we say, that's good, I like that, we're going to hit OK. Next, we're going to pick the bottom of the object, and this plane, they call it the top plane, we're going to hit OK. Done. And then we're going to pick the side wall, this side wall of the object, and then we're going to rotate this bit, pick this right plane, voila, and we're done. Okay, looks good. We're going to hit OK. We're done. Did you see I had to do OK 3 times? Did you catch that? There are a lot of people that want to get it all done in one shot. It is physically impossible. Okay, there we go. See that? All I did was undo back to this position. Did you notice how the plane went over there? Did the plane really get moved out of the way? Where did the plane go? It's still lined up. Remember that from when you were working with modeling. See? It's still lined up. Moving it back and forth is a meaningless activity. I'm not moving the part. If I stretched it out, that's all I'm doing is stretching it out. I'm not really changing anything. Just remember that. It gets confusing when you're in the 3rd dimension and in assembly. You almost think like you're moving something. You're not moving anything when you're doing this. Okay? Just remember that. One more time. Mate. Pick the front plane. Orbit about a bit. Pick the back of the object. It's attached. We hit OK over here. Okay? Then we pick the next one. The bottom of the object. And this plane. And it drops down. We OK this. Then the last one will be the right plane with the side of the object. I gotta zoom in for that one. And voila, and we OK that. 3, and then we're done with the command. We're gonna hit OK all the way out. 3 mates, 3 contact points. See that? And when you click on these, they'll tell you what's connected to what. I do like the color change in here. Purple versus, okay, that's still purple, and that's still, okay, fine. Purple, that's what we're going with. Got it? What's nice, when you connect something in 3 positions, guess what you've done? You've locked it down. It's just like with GPS. 3 points that are used to figure out where something is. That's how GPS works. And it's the same here. You would use 3 points to control this. It's how you control a feature. Just like a stool, can't stand with 2 points, but you can stand with 3 legs, right? 3-legged stools are possible. 2-legged stools are not. FYI. That's right. It's called a balancing act. You got it. So here we go. So this object is constrained in the most natural manner through physical contact with the natural planes that we want to work with. Now everything goes on top of this thing. So here it goes. We've got this object here. Now how many of these do we need? We need 2, correct? So I click on this, I Control C, and then Control V. Up, and I get this. Gosh darn it, gee willikers. Okay, look what I tried to do. Highlighted the object, and did a Control C, correct? Clicked away from it, then did Control V. Oh crap, why did it work this time? Gosh darn gee willikers. Okay, watch what I did. Okay, watch. First time, what did I pick? I picked the face. I did Control C, clicked away, Control V, got the error message. Got it? You're like, gosh darn it, you willikers, it's not working. And then the next time, I highlighted the whole thing. Do you see that? I highlighted the whole thing, then did Control C, clicked away, Control V. That is how you copy and paste quickly. One more time. I see the look on the people's faces. If I pick on this face, or pick on any face of it, I don't care. Let me pick a different face. If I pick on a face of a part and did Control C, the computer is not smart enough to know that I want to actually copy the whole thing. It thinks I only want to copy literally the item I selected, which is just that face. So that's why when I do Control V, it errors and says the item in the clipboard cannot be pasted. Because that's all it copied was literally that one highlighted face that I clicked on. Okay? Even though I'm in assembly, it doesn't know. Only if I make a crossing window and pick the whole object. Okay? And then do Control C and click away, Control V. Only then does it know that it's really the part I'm trying to copy. The other way to do it, because you know there's always more than one way, click on the part in here, if you can find it. So if I click on this, I find that it's here. When you notice when you click on it, the whole thing goes blue, right? Remember that? I was saying that to you before. The object that's selected turns blue and everything else is grayish. That's how that happens. I can do Control C from here. Click away and Control V. Same result. Okay? The other method, the slowest method, that's how, to show you the last method is the worst method. Insert component, go find it, and bracket, and hit open, and drop it. Too many steps for me. All right? So you do what you want, but those are the different ways to make duplicate copies of an item. The neat part is every time you do it, now I think I brought this in I did. I brought it in like 6 times. Every time an item is brought back, remember just like when you're doing sectional views, every time you do sectional view, it just switches to the next letter. So maybe you tried it 10 times, so that's A, B, C, D, E, F, G, H, I, J. So you try to turn something into me with a section view K, and I'm like, well, where are the other 10 views? No, those were bad ones, and I just redid them a few times. Remember how I told you to reset them to A? Well, that's kind of what happens here. It shows up multiple times. Now we'll see if it affects our detail drawing. We'll see later. So we'll see what happens. I don't know if it will. We'll find out. So we've got this part here, and we've got this part here. Now one is facing the correct way in the sense that I do want to take this one and align it with the top of this, right? I want it to go somewhere up here and line up with this piece, right? Now, do I need to go through all this gymnastics effort of, oh, let's move this over? And no, you don't need to do any of this stuff. Here's what you do. You go back to mate. You want the center of this, the center of this, the center of this. Now, this is difficult to find, to be honest. The center of this, because that's a helix. It's kind of tough to find the center of that. I'm going to go over here and I want to find the center of this. Let's see what happens. Ooh, it lined up kind of nice. Let's see. Before you hit OK, I recommend that you check the side. That looks good. Check the front. That looks good. You're good. When you hit OK, that's what it did. It lined it up on centers. Now you'll notice you can wiggle this around. That's okay for now. It'll straighten itself up later. Just like if you had it and you put a fastener in, what do you notice about the fastener? The thing wiggles while you're fastening something down, right? Now the only question I have is whether or not this top part was supposed to be threaded or a through hole. That's supposed to be a through hole, isn't it? Yeah, this is supposed to be a through hole, but that's okay. We can fix that. Don't worry about it. No big deal. Okay? Not a big deal. Okay, so here's this one. Now I've got this guy. If I had a middle plane, I could have mirrored this. If I had a center plane. But I don't, so that's okay. Now this one, the same thing. I'm going to do it again. I'm going to go to mate. I'm going to zoom in close. Hopefully pick a side wall. I'm actually picking the cone part because I know that's centered. Go down here. And I'm picking this side wall here. And it lined up beautifully. And I'm going to hit OK. And then all I'm going to do is twirl it around so it faces the correct direction. See, it doesn't take a lot of effort. Don't worry about it. Don't stress out about that. This guy, we know is on centers to this guy. So now we're going to go back to mate. We're going to pick the inside wall, inside wall, inside wall of the hole. Some people say, well, you could just pick this. It's good enough. I'm like, the inside wall will automatically give me center. If I pick this, it might actually give me tangent or touching to that face, which I might not want. If all I'm looking to do is center objects, I would pick the inside wall. Inside wall. And then in here, I would do the same, inside wall. Because I want to line them up. I'm going to cancel that out. I want to line them up so I can do this. I can pull this out if I need to. Okay? If I don't use inside wall, let's just, for the sake of argument, whatever you want to call it, let's not do inside wall. I'm going to go to mate. I'm going to pick this just the round part. That edge of the hole. See that? I only picked the edge of the hole. I didn't pick the inside wall. And then let's say I picked just the edge of this hole. They connect. And that's it. They stay together. Because I picked circle and circle and they connected to each other and that's it. I can't push them away from each other. The mate was a bad mate. So if I had that situation, all I do is click on it and just right mouse button and delete it. That's it. Then you can pull it out and do this correctly. The mate that you're looking for is inside wall to inside wall. That lines them up so that I can move it, but they stay centered to each other. Okay? Those are the subtle things that you want to know. Now, let's say I did it this way and I totally forgot. Whoops. Whoa. Sorry, hit the wrong button there. Let me do mate again. I'm going to pick this inside wall. And then I pick this. Now notice, are they facing the correct direction to each other? The what direction I want them to face? I'm going to pick this inside wall. And I'm like, oh man, how do I fix that? Gosh darn it, gee willikers. If you scroll further down on the left side, you have something, mate alignment, which means that they're going to stay the way that they way you see them, or, watch this, anti-alignment. Whee! See that? Okay, one more time, there's nothing up my sleeve. Alright, let me cancel out real quick. Okay, here's this item. Let me turn the planes off, because for now, I'm going to go to view, hide, show. I'm going to turn the planes off just for this conversation so you can clearly see what's about to happen. I'm going to hit mate. I'm going to pick this inside wall. I'm going to pick this inside wall. They line up, but they're lining up the wrong way. I want them to turn and face each other. Okay? If you have a lineup that occurs this way and you want them to turn around to each other, on the left side in the model tree, if you look at the mate selection, all these little options, skip them all. Down here it says mate alignment. This is aligned. That's the way you see it. And then when you pick this option, anti-alignment, watch, click, whee! It rotates it. Now you might ask the question, why did it rotate this and not that? To be honest, it's the second one selected, not the first one. Let's try it the other way just for fun. Because remember, I picked this first and this. Let's see. It might still do pick randomly. We'll see. Let's try it. Whoops, I don't want to insert any. Okay, go to mate. I'm going to pick, this is my first object, and this is my second object. Ooh, it still rotated it. Okay, and then I scroll down here, and then I flip it. Okay, so what could be different? Did I already make this to something else? Yeah, I did. I made it into this guy, right? And did I make this to something else? Yeah, I did. I made it into this center. Did you hear that? So this piece is locked in place. It's locked here. So you might say, well, why didn't it rotate the whole thing? Because it can't. It can't rotate this piece at all. It's stuck. So the previous mates in your model, in your assembly of your different models, affects what kind of mates you can and can't use. Okay? So keep that in mind because you'll probably get an error message. I did not, because let me make an error. Okay, I'm going to intentionally say I want this face to be parallel to this face. Okay, to this face. See that? I want these two to be parallel to each other. Okay? And now I'm going to say I want this center and this center to align with each other. And then I want to flip them. Now look what it did. You see that? I have one constraint fighting another constraint. So now it did do exactly what we questioned, why didn't it do this, which is literally rotate the entire item to the other side. Do you see that? See? That's how this product can work. I have a couple of things that are going on. So if you see on some unpredictable outcomes, you're like, wait a minute, why did it do that? First, check what your mates are. And the nice part is to delete your mates, you go into the section here by mates, and just delete them. It's okay. You can just click on them, right mouse button, and delete them. Everything's fixable. That's the beauty of these things. Okay? So don't stress out over any of it. If it goes the wrong way, just undo. It's okay. Or reassemble it. It's okay. Don't worry about it. As you play with this more and more, you'll find out how it behaves. So back to mate. Back to this guy and this guy. Inside wall, inside wall. I'm giving you what I suggest you do. But I know you want to play with it, so I want you to play with it and experience all the joys of playing, of watching it misbehave, or some of the things that'll happen. Okay, and that's all right. Now the next main I want to do is inside wall. Inside of that, it's a thread, so it's a little more challenging. And inside of that, ooh, interesting. I wanted to do tangent. I don't want to do tangent. I don't want them to be tangent. I just want it to be a line. Okay, let's try this one more time. Mate, inside wall, as inside of the wall I could find for a cylindrical part. There's that inside wall. Now let's see what it did. Okay, there we go. Yeah, it's aligned. Looks good. We hit OK. So now this will go up and down, these two, and this thing will twirl in the middle of it. If I try to drag it a little bit, let me try to, it's a little difficult to make it spin. If I lock this down, it'll start, this center piece, there it goes, will spin. See how it spins back and forth? Whee! Okay, just be aware of that. So the last thing you can do if you want to is just go to face, whoops, did not want to do that. X out of that one. You have to be careful not to have selected something when you're going to make. And I had, because I was spinning it back and forth, I had it selected by accident. I want to pick the bottom of this object and the top of this object. By doing that, now this object will not move anymore. This will be stationary and this will be stationary. This guy in the middle will spin. Now the same thing, do we really want this doing this? No. It is a very good idea to make the side wall to the side wall and hit OK. Now technically this part will spin because the only thing holding it in place is what? A bolt. So the pressure of the bolt and the nut are actually is what's holding it in place. So this is a good way to test the design. Is this a good design? Do I want this piece spinning? Maybe I do. Because technically, in the position that it's attached, do you see how it's got a gap? If you look at the assembly and you look at the front view, this thing has a gap in it. See that? It will rotate back and forth because there's a gap. And that might be okay. That could be by design. We don't know. But if we look at the original part, and we get really close to the picture of the baby assembly, it's got a gap there too. So it has a gap. Maybe it's supposed to spin back and forth. It's a drill jig. Okay? So we ask ourselves, well, what is a drill jig? Let's go look. When we look at drill jig online, that's what it is. It's supposed to have a little bit of flex to it, because what you're trying to do is control where it drills. This one's a very precise drill jig of how it will stay in one position. Okay? This one's at an angle. This one's at, let's see, a Drill Master Portable Pocket Hole Jig Kit. So it's basically a guide for your drill. Okay? So that's what it is. So that might need to rotate a little bit, and you're controlling which way the drill goes with it. Okay? So it might need a little play, is what I'm saying. Now let's go ahead and mate. Now we're going to insert, let's see, we're going to pick the round part of this body. The round part of this body. They're aligned. We hit OK. And then if we want it to be seated up against it, we'll pick the inside wall and inside wall. And that's good. Okay. Now we can rinse and repeat. Gosh darn gee willikers. I want a copy of that. I forgot how to do that. I just pick on a part of it, right?
Yeah.
Well, I can't mirror because there's a small problem with mirror. Mirror requires that I have a plane to mirror with. Now, when I turn this on, that's a good idea. I like that idea. It would be nice if I could mirror it. But I don't have a plane that is centered to this object, center. So I can add one, of course, and maybe that's a good idea. So let's do it just for fun. I need my planes on for this. So now if I want to not see so many planes, I actually have to go into these and turn their planes off. So For this guy, the planes are off. But let's see, maybe the base has planes on. Yep, so I'd have to turn these planes off. There we go. So that way the only planes I'll have access to is the main plane. There we go. Turn those off individually. So I could add a plane. Now I can add a plane from the middle of this point and the middle of the back of this object. Hold on. Or I could just pick that. See that? Because I know the end is attached to this end, and hit OK. So now I do have a plane in the center. Now, do I want a mirror now? Yeah, let's do it now. Doesn't matter. Let's go ahead and do it. So now we're going to mirror this component. Do I want that? No! Mirror plane. Oh, the first thing it wants isn't the component. Remember how many times I say get your hand off the mouse? I want you to read. When it comes to SolidWorks, there's no pop-up, dialogue, communication, nothing. You got to look on the left side, whatever's in blue, that's what it wants to do. Okay? So if the first thing it wants to do is pick the mirror plane, that's what you pick. Then it jumps to the component, then you pick the component. Okay? When you hit OK, voila, there's your other part. When I rotate this guy, the other part rotates with it. It is a mirror of it. So you can do that whole mind thing. Wave, it waves, get it? But at the same time. One thing you will notice though, when you pick it, because here it is, that's this item. Okay, now how many items do you see here? How many times do you see it listed? Flat head, hex head bolt, hex head nut. That's this dude over here. Okay, see that? And you've got the, oh, I gotta minimize. Yeah, you only see it once, don't you? Let me double click to close these out so you can see the other parts. I had opened them when I turned off the planes. So you see, this guy you see multiple times. This is the one you need to get rid of. This item right here. What is this one again? That's this one. Right mouse button and delete. All you do is get rid of that one. So, but you only see this listed once. Whenever you mirror, you only see the item once. Whenever you mirror, you only see the item once. And it is a complete partner to its original. See that? Whatever you do to the original happens to the mirror. It's like the right and left hand of it. Does that make sense? Just be aware of that. So if I wanted to align, for example, this face, and I wanted to align it to this face, I won't get that option easily. Align it to this face. It won't happen. It doesn't want to do it. So let's go to mate. I want to pick parallel. I'm going to pick this face to this face. There we go. And it did finally rotate it. But I had to intentionally pick parallel. For some reason, it wouldn't do it otherwise. That's how I would be. And they both move together. Okay, both sides of the mirror. Now, if I take this guy, this is the other fastener here. Okay. And I want to align it, let's say back to this one. I pick this up, this interior wall. Oh, this is fun. To this flat surface. See how it rotates and moves it in position? See that? That's the easy, quote-unquote easy part. We hit OK. Now we find out the problem. Okay, we talked about this already. The fastener and the hole don't match. You have to modify this to fit that. Otherwise, what you're going to have is the following. When you make these two, just to align with each other, they're not going to because they can't. Okay, I'm gonna try to make them mate. It just won't work. Let's try it again. Mate, I'm waiting, I want the error message to appear. I'm gonna pick this side wall, and I'm gonna pick this interior wall. The only thing it wants to do is constrain. Coincident, you're gonna get this kind of error message, unable to mate selected entities. Okay, and if I pick this face and say, fine, I don't care, pick this face, pick these two faces together, for example, and hit mate, what do you notice is happening there? They're literally in each other. They physically are, it's from a physics perspective, impossible to occur, what I just did. And if I did an evaluation, just for fun, let me X out of this real quick, and I asked for interference detection, oh yeah, that's called interference. Okay, and calculated it, you should see a big red ring. There we go. See that big red ring? It's interfering in multiple spots. See, what, interference 1, interference 2. See that? See what you, that's where you're having the problem. Notice that? So that's what makes you understand that you have to change something about your part. Okay? Because it obviously doesn't work. Now the funny part is the only place that you see the interference for the thread is where? At the bottom. You don't see it on the top one. Why? Because technically the hole is bigger than the thread. Yeah, it's a clearance hole. It's the only reason that there's no interference up there. In this neck of the part. Because the hole itself is physically bigger than the thread. Because that's how it was drawn or requested. So with that in mind, you realize what you have to change. It's a straightforward fix. You've got to change that L bracket to accommodate the fastener if you want the fastener to be flush. So if I delete that constraint, that mate, and pull this part out, I can go and fix this guy. I can go ahead and actually open this part and fix it. So I have the option to open part. I also have the option to edit the part. If I click edit the part, you always have to save the document before you do what I'm doing. If you edit the part, you'll notice how in place, you'll notice how everything else ghosts out, and the only part that's active is the one you're working on. Now I know what I gotta fix. I gotta look at this part, and that's how they show you the part you're working on versus the stuff you're not. The part you're working on is blue. The stuff you're not working on is black. Again, not very obvious, especially if you're colorblind. Blue and black are very close colors to you. Other products will like darken everything else out, and the only thing active is clearly visible. So you will have to work on that. If you look at this end bracket, let's see what it is about it. Let's see what we could do to fix it.
I just redid it. I had to cut out the cut extrude one on the bottom, the
Yeah.
3,
Yep.
and then the pause extrude 2.
Yeah, I'm going to delete the thread because we don't need the thread technically. Let's go ahead and edit the feature of that hole. Instead of 82, we're going to pick 90. Diameter, inside diameter, outside diameter. We do have 20 millimeters on the outside. That's good. So that was right. Because is it 20 or 22? What size is that head? No. I mean the McMaster car. I thought the McMaster car head is 22.
Oh.
Yeah, it is.
Yeah,
It's 22. Yeah, so that has to change. That head is 22 millimeters at top. If we hit OK, and then we OK back to our assembly, oh yeah, that'll fit. Now when we go and make a mate, we're going to pick that interior countersink, pick the interior head, look at that. We're going to hit OK. Now let's see. Now we should still get the error message on the bottom for the threaded part, because obviously that's where it engages. But let's evaluate this. Let's see what kind of interference fit we have here between this dude, and we'll pick that dude for fun and calculate. We should get 1. There we go. And that's it. We got exactly what I thought we would get. We got 1. And that's at the bottom where it engages the thread. See? At the bottom where it engages the thread. That's okay. Here, it's a through hole. The engagement is through. And that's okay. When we hit OK, we know what's going on. If we want to, we can split this part in half so that we could see through it. What's the only problem we have? Do we have a plane through the center of this thing? Yeah, we do, but in the wrong direction, right? So let's throw in another plane. Let's go to assembly, and we go to reference and plane. And now we're going to pick, let's say, come on you, the mid plane of that, okay? And that's good enough. That's all we need, right? We need it through the middle. Yep, we're good. We're going to hit OK. Rebuild warning. What's the rebuild warning? Okay, fine. I'll pick the other one. There we go. Is that good enough? No, no. What's the last thing you think it needs? Alignment. It needs to be parallel. I don't want it there, though. I don't want it aligned. I don't want it to be coincident with the existing plane. I want it to go through the middle of that one. So I have to pick 3 points that are actually correlated to that object, just like that. Then I hit OK. Now I can go to section and pick this plane. I don't want to pick a front plane or top. What plane do I want to pick? The one I just created, right? This one or this one? This one. There you go. When I hit OK, now I can see. Oh, it doesn't like me selecting that. Is it because this isn't parallel? Let's find out. But what I'm doing right now, the quick way to get to mate, if you hold your control key down, remember how the quick way to get to constraints was? Remember that when I told you just hold the control key down, pick the item, and you see it on the left side? Well, guess what? If I pick 2 solid bodies, okay, and jump to mate, it'll automatically position it to what makes the most sense to what I did, which was I wanted them to be parallel. Little tricks. Now let me see if the plane thing will work, because all I want to do is see the section of it. There we go. Now it should work. Still doesn't like it. What doesn't it like? I don't understand. I put a plane in there. See that? There's the plane. See where the interferences are? They're right there. They're in the threads. And that's okay. It's very difficult to line them up perfectly when you do a physical thread like that. But you see the through hole? See that? It matches beautifully. There's the fastener. That's a tight fit, but it works. So it won't let me create the sectional view for some reason here in assembly, but that's okay. Next, I'm going to go to mate. I've got my actual nut right here. I've got to pick. You're trying to pick that flat wall. The flat wall, that's the tough part. Trying to pick the flat wall, not the curve, not the helix, but the flat wall. That can be a little difficult. Did it do it? Yeah, it did it. The question is, where did it go? This will happen, by the way. And then you'll sit there, where did the nut go? It's going to drive me nuts. No, it's not. Here, what you do is you find the item that seems to have disappeared, and I'm saying that in quotes, air quotes, disappeared, okay, which is the nut, and you find out where did you go. Okay, when you see where it went, looks like it's stuck inside the part. So here's what you do. The reason you say that is, the reason I say that is because if you look at where the nut is, you see how you see that little orange? It's inside the part. You're like, aha, you're hiding in there. So you pick this item, okay, which is, I picked the face of the item. What should I pick? I should pick this, the end bracket. See how the whole thing turned blue? Okay. I can make it transparent. I can change it. Okay. I can hide it from visibility. It's not transparent, sadly, but I can hide it, which I just did. I didn't delete it, but then I could see where my nut is, so I could pull it out, put it where it belongs. And then I could unhide it, show my component. Okay, watch. Click on the item in question. Hide component. Okay. Click on it. Show component. Got it? So if something quote unquote disappears, that's what you do. That's how you can find it. Find it. Get it? Relocate it. It didn't disappear. It's there. It's probably buried in a part. Okay. The last thing, because I'm slightly obnoxious, I would want these to be parallel to each other. Did you see that? I hit OK. So that way the slot, is parallel. Of course, I'd want the nut to be parallel. I want this and this to be parallel. Want that, obviously. I want the nut to be flush to that surface, right? Okay, see that? Those are the things I'd want. Cool? And then I'd be like, oh gosh darn gee willikers. I gotta recreate this on the other side. I'm too lazy for that. What can I do? I mirrored one component. What do you think? Mirror. But I can just go ahead and edit my mirror and pick the other components. And when I hit OK, I'm going to move over here so you can see what's going to happen. Let me move this over. When I hit OK, it appears on the other side. So I can add to an existing mirror. I don't have to make a new mirror. Get it? All right? I'm just giving you a bunch of information all in one shot to try to show you all the different things you can do. Once this part is done, I hit save, save, and save often. You've already heard the bad joke out of me on that one. Okay, save all. Okay, next I can go ahead and file, make a drawing from assembly. Now it's metric because it's a metric part, so you got to intentionally turn that off and pick ANSI, because we only have 8.5 by 11 paper in this building. We don't have A4 paper. And then here's the neat part. I'm going to drag in the isometric one. Isn't that beautiful? And that's the one I want to build my bill of material from. Now you'll notice it dragged in whatever was visible. See that sketch, that annoying little sketch stuff? Why is that showing up? Because it was in the actual assembly visible. See, it was visible in here. Why? Because I was looking at it. Remember when we were editing it, when we changed the counterbore information? That's why. Countersink, I mean. That's the reason. So if I look at my, which bracket was it? The end bracket, yeah. When I look at this, in here, that sketch was visible. There's the sketches. These two sketches, if I remember, not those two. Is it this one? Yeah, this one? Yep, that was visible. No. So we've got extra. It's an end bracket, right? So let me open it. Let me edit the part. So I can look at which. That sketch is fine. It should be here. Oh, that's the other hole. Okay, then it should be in this one.
It's a screw, isn't it?
Yeah, that's what I think it is, but for some reason, I do. Maybe it's that one. No, that says show. I don't want it. No, I don't want it to show. So it's not visible, so the question is, why is it visible? So let's open it. Okay, it's not visible here. But it's visible here. Oh, the question is, does it really belong to that? Maybe it doesn't.
Draw the,
I did not. This is another person's drawing. So what I'm going to do, aha! There it is. It didn't even belong to it. It came with a fastener. That sketch belongs to the fastener. So we're going to edit that item, not that feature. We're going to edit the fastener itself. So in here, the sketch is somewhere in here visible. Okay, there we go. Turn that one off. A lot of sketches are visible. So let's see. That one's now no longer visible. This one is still visible. There we go. That's what it was. The sketch wasn't part of your part. The sketch that was visible was part of the fastener. See that? So it took a little bit of investigating to figure that out. So now I can turn this part back on. I forgot how to do that. What do I want to do? Which one, guys? Is it this one or this one? This one or this one? Show component. Got it? Remember that. Okay? So I'm going to hit save, and save often. Never a bad time to save. Just like there's never a bad time to apply for financial aid. FAFSA, do it right away. So now when we go back to the detail drawing, this should update. It did not, so let's refresh it. Come on. Sacre bleu. It didn't do it. So let me get rid of it. I don't know why it didn't do it. So let me refresh this one. Still shows it with the, wow, that's annoying. All right, so let's go ahead and go to Model View, Assembly. Let's browse. I did hit save, right? Didn't I? Did I hit save on that one? Thought I did. I'm going to save one more time. I did. I did hit save. Whoops, minimize that. Model View. Yes, selected a drawing. I could double click. If I click on this, then I could change it to isometric. And now it's good. Now it shows correctly. So I guess I have to reinsert it, which is annoying. You know how to tweak the border, right? We've done this enough times, where you need to basically take out all the junk, because otherwise it just hogs up your drawing. Just remember that. You want to clean up your drawing. because that one you have no control over. You don't want an overbearing border. But this guy, you want to change the scale because you want to make this as large as possible. So we're going to use a custom scale. Let's see if 101, 101's a little too big. You're going to user define. What do you think? 101's way too large. 5/8? Not bad. If you want to use 5/8. If you want to use like my other class, for example, they actually are doing like a front view and a top view. You can just bring in the standard views. Meaning, you can go over here. Come on. Refresh. There we go. You could bring in the one primary view, okay? You could bring in this top view, hit OK. I would actually go the opposite direction. Keep this guy. And create a sectional of all things. Of this guy. Why does it not like it? Did you notice that? Didn't come out right. So let's see what that error message was. Through the center, we're going to hit OK. We're going to do auto hatch. Exclude. We can exclude. Let's see what excluding fasteners will look like. Let's say OK. Remember how we got the same error message when we were in the assembly? We're getting it again. So the components which are failing is the base. It's all about the base. As always. So that is why we're getting OD green. It's not working well. So that you'll have to figure out. Something's wrong with the base. I don't know what. You'll have to check that out. Sorry. So the maker of the drawing will have to find out what's going on with that, because I don't know. So my solution, of course, is I really don't need a sectional view. What can I get away with? What do I really need? Will you stop that? Huh? Yeah, I can get away with the isometric. So I'm going to go over here and just drag the isometric in. See stars, don't you see stars? Okay, is the scale good? No. What do we want the scale to be? Is that 5/8? Okay. So we're going to go up here, user define, 5/8. We're going to say OK for today's conversation. Okay. I would like to fix whatever is going wrong with it, but for now, just to get through this conversation. Those little stars are annoying. I could always hide them. See? You can always hide things that are in the picture that you don't like. FYI. Just like you do on your detail drawings already. Now the last step is putting in the bill. So when you go to annotation, at the far right end is something called tables. And I know tables to you might not mean a bill of material, because if you're used to AutoCAD, table is just creating a table. It's not content filled. In here, when you click down on the arrow, you'll actually see bill of material. It's not the first option, it's the third option down. Okay? Then select the view. I usually just select the whole thing. Standard bill of material, hit OK, and voila. Now here's the key. This actually operates very much like Excel. Why? Because it actually uses Excel. So I can hold down the contents of a column and drag it to another position. I can eliminate a column. I can click on that column, right mouse button, and just delete that column. Okay, I can change the width of my columns the same way I would in Excel. See that? See, I can make it tinier, longer, whatever. And then I could drag it over and get it to snap in the corner. Okay, you'll see that the widths of the columns, if I click on everything, see how it's got a 0.5 millimeter wide. Let's say I wanted everything to be 1 millimeter, and it'll scrunch it through that. See that? If I picked everything, and let's say I made it a more 2 millimeters, see how it widened everything up? You can do stuff like that in here. I think, let's do 1.5 for fun. Whatever the file name is, that's literally what it makes the part number. So whatever you make your file name is the part number. If you don't want that to be the file name, if you don't want that to be the part number, then you have to input it within each item. Okay, so for example, see, here's the actual file name. It starts with 91430A168. Remember how I told you, and here's your hex head nut? That's the file name, is here. Oh, you see over here what it says display state? Guess who put that in there? McMaster did. See right there? That's going to be the display. They put their part number. They didn't give you the whole file name. So your base didn't have that, right? So it doesn't have a default display. Okay, if I open my part and look at it, and I click on my base, right mouse button, and I have, what do I have? Document properties. These are the document properties. Then I have system options. Under document properties, what else do I have in here? I've got model display. That's how the object looks. That's not what I want. What do I want? There's something about this part. I've got the opportunity. See over here, I've got properties manager. Select an entity to view the properties. See, that's just viewing the properties. Then I have configuration, the default, base. Then I have something called the base, the annotation, notes about my object. Then I have over here the renderings about the object. When I go back to the model, though, I don't have the content of what do I want this model to be called outside of this drawing. If I go to the configuration processor, all this does is tell me all the different elements that are in my part. Okay? Not a valid design table. Fine. It's supposed to give me a couple of things in here, but I never did anything to this part. Is this the part that's also a problem? Is this the problem child part? I think so. This is the one that won't do a sectional because of this base.
Oh, yeah, the sectional.
Yeah, there's something going on with this base. Maybe it's a thread. For now, I'm going to ignore it because I need to at least show you how to work with the naming your parts. The easiest way to get the part name correct is by how you name the file. So if you want it to say base, which is fine, just make it capital letters. Rename the file BASE with capital letters. But here's the funny part, just for fun. Let's say I do it outside of here. This is the thing that I know that I need you to be fully aware of. When I go in here and change something, specifically on the items that, like, let's say I'm going to rename this thing and call it base. Okay? I'm going to rename center plate and call it center plate, same caps. Rename end bracket and call it end bracket. Okay? Just in caps, that's all I did. Only change I made. When I go to my assembly, the detail drawing of my assembly, in a few minutes you'll get it. I'm going to pause the video for a second while this is happening. This works. Okay. So now we're back in. I just took it off pause. So in here, this isn't refreshed. You notice that? If I update this, the assembly drawing didn't change. Even though everything else turned into caps, the default display, there's all that default. We don't have here, this bill of material did not update. Okay, right here. If I delete this bill and bring in a new bill, then it's all caps. I can delete that column. I can move this over. But that's the annoying part. You notice how it doesn't update itself? What did I have to do, guys? Delete it and bring it back in. It's probably the most annoying thing about it. Doesn't auto update the bill, which is really annoying. So even though I fixed them, it didn't auto update. If you pick each item, you could do a right mouse button, and you could do a couple of different. You see how you can open the part. You can do formatting on it, column widths, everything. Okay. When you double click on this, you actually are editing this directly. When I double click on this, when you double click on any of the cells like these, you'll get this error message. It's parametrically linked to a part or an assembly document. Manually overriding the value will sever the link. When you do that, that's what you have to appreciate. You're severing the link, which means you're always going to be bringing that bill of material in and out constantly, rebuilding it. Okay? So your goal is not to do that, but a lot of people do that. They'll customize this because this doesn't update naturally anyways. Okay? It doesn't have a clean update feature. For now, I'll show you how to at least, that's when you change it to caps, that's a simple solution. Get it? Just delete it and put it back in. I really don't want you to rearrange or change the content because when you do this, you see what happens? If you double click in a field and you want to change it, you're breaking the link. It's no longer naturally connected. You'd like to avoid that, okay? Before I go into changing it, I want to show you how to add the balloons. Now you'll notice I dropped the balloon over there with the question mark, but if I touch something real, I won't get a question mark because it knows what it's doing. The only reason that one out there is a question mark is because I did what? Drop it out there. See that? If you drop them out here, guess what they look like? Bunch of question marks. Okay? And then you're like, why is that there? Well, that's why. If you ever wonder where do the question mark ones came from, they came from you clicking. So be aware that that's how balloon works. When you click auto balloon, okay, let me open this up a little bit on the side here. When you pick this object, notice what it does. Drops them all in one shot. Maybe not exactly the way you want them in there, but it drops them all in. When you hit OK to that, then all you have to do is locate them in a more advantageous position. Get it? Put it in a better spot where it's clearer to whoever the viewer of the images, not you, because you know what the drawing is. You're the maker of it, right? Doesn't matter that you know what it is. See that? You want to make sure other people can understand this thing. So I usually like to position my arrows either right on the part, which turns it into a dot. See that? You're going to have something that looks like that. Okay? That's the simple approach to making an assembly. Okay? Now, if you look at your bill of materials, you could right mouse button it, and you can delete it. You can do a save as. You can actually save the bill out, like an Excel spreadsheet. So if you do save as, You have a template option or you have the Excel option. See that? Now if I save it out as an Excel, just call it drill jig. Some people might ask, why on earth would you want an Excel spreadsheet created of that? Well, maybe I'm trying to put together also a cost sheet. There are my part numbers. See? Because let's say I prototyped the heck out of this thing and I wasn't keeping a track of what components I was dragging in. Get it? And I'm like, whoa, whoa, whoa. Now I need to put the cost sheet together on this. This is one way to do that. Okay? One way. Not the only way. I'm just showing you a simple way. The other way is you actually incorporate, which is a little tougher for most businesses, which unless you're using some type of data management system, an EDM, engineering, drawing, management type system where you're connecting your costs to your models. That's the other way. And you literally will have a running cost sheet being created while you're making your model. That requires a little extra work. And some companies do that. Okay? And you'll find out at the company you're at. Yes?
That it shows the quality of weight or...
Oh, you're talking, not in here. If I'm looking at my model, if you want to go to the, not go, I go and I typed it because I said go and that's what I did. If I'm in here, okay, and you're looking for some physical properties, you want to evaluate the model, you can do different types of elements. Let's say you wanted to check hole alignment. Is everything aligned? You calculate it. Everything should. It says no misaligned holes. That's good. If you're looking at mass properties, if that's what you're thinking, this is your mass properties of this entire thing. This is 858 grams based on the material, which we really haven't defined. Let's keep that in mind. So if we want to define material, the only material that might be defined are the fasteners. The base, however, doesn't have material defined to it. If I open it, this thing doesn't have any, like if I look at annotations, materials not specified. So if I edit the material, 1020 steel, hit apply to that. Okay, close it. See, I've assigned the material. By assigning a material, I've assigned the physics properties associated with that material. Now in here, if I pick this, I should get a different value. Yeah, see now I get 4,000 grams. So all of a sudden, it was only 800 something. Why? Because probably the only thing it was measuring was the fasteners. Because the fastener they assigned material to, because that came from another party. But my parts, the material wasn't assigned to them. Get it? So as you do that better, as you assign the correct materials to each part, then this starts becoming more accurate.
In the Excel, we can have the column of the weight.
You can, yeah, you can start adding more columns to what you're going to create. Yeah. So you have the option copy to clipboard if you want to copy the content. Okay. A couple of different things you can do. So if you look at each part, like if I open the base again, in here, what did I say? Annotation. We've got this. Annotations about the part. We don't have any annotations on this guy. We have the material property now. No sensors, no history is how the part was made. We don't really have a list of content on this part. So we've got I don't see anything major. Appearance, material. We pick a material. appearances default to whatever it is. Get added to the library for future use. We don't use a design library though, so we don't do that in this class. So I don't have to do that. So, but material will define its physics properties. That's probably the best way to answer your question. And then here's your assembly, and then out of your assembly comes your disassembly, which includes the drawing itself with the bill of material. Back here, though, let's say what I really wanted is for this to be broken up, exploded. I don't want it to be all connected this way. Under assembly, I have something called exploded view. Let me show you that. And in here, I can literally take each of these components and pull them, whoops, and that can happen too. Let me try that one more time. Take each of my components, see this arrow, and pull them out. Okay? And then if I do it to every component, let's say I drag this out, drag that out, and drag this way, drag this way, see that? Can't drag that one out yet, gotta drag this one further out. Whoops, those two went together, so that's a no-go. See that guy? Delete that stuff, see that? Drag this further out, so therefore I can drag this out and drag that one out. I can drag this one out, so that I can drag that one back for some reason, this one forward for some reason, see that? When I hit OK to this, and if I hit save, should, but we'll see. We go to my assembly does not update, see that? And perhaps that's not what I wanted to do. If I refresh my options from my palette, one of them is an isometric exploded. See that? So I can choose it. Here's the other neat part that you could do. By the act of doing that, I created a video. Right here. Here's the video I created. Animated. Isn't that cool? So when I open this up, come on you. Oh, it's up there. Hello. The dialog box was hiding in plain sight. If I change it to go slower, and I hit play, see that? And then let's say I want to record my creation just for fun. See that? And it saved it where? Did it save it in that folder? Yeah, it did, right there. Saves it as an AVI file, and here it goes. Oh!
What?
Seriously? Okay, that's probably, I had this problem with that actual recording, not like a DVD player. I think it's something about this computer, so it's not the video, it's, I think, how they set up this computer. Something about, no, because I can't play DVDs on this particular computer. So I think it's something about this. If I upload it to YouTube, it might play. So, but it creates a video, is the point. Now let me see if I could change the kind of I don't want to do a bunch of bitmaps. It's like AVI file is the only option I really have there. Sorry about that. But here, you can see it play. It does play differently when you record it as a video. They're never as smooth, I'll tell you that. But that's it. That's what you would do. Done. So you can literally create a baby video of your assembly and just show to somebody real quick, this is how you assemble it. Or this is how you disassemble it. Cool? And you can send it over to them and let them watch it. So that's assembly, and this is the detail drawing of that assembly. So the same place you create detail drawings is the same place, for part files, the same place you create detail drawings with an assembly. The way the balloons work is this: individual or auto, and it'll do everything, populated everywhere. Is it perfect? No. I have yet to find a program that is, to be honest, when it comes to detailing. It just does what it does. So you'll have to edit it, anticipate having to fix it. This is the simple version of assembly, just so at least you could do it, because you guys have never done one at all. Can I get into deeper conversations about editing everything under the sun? Yes, I won't, not for this video. Okay, I'm trying to keep it simple before I go down the rabbit hole of the details. I started doing that and I stopped myself. Cool? All right, so you got the basics. We're going to leave the part numbers the way they are. I showed you the simple fix to that. If I wanted all caps. Oh, I did forget to do this. Okay, hold on. I got to do one more thing for you, because I know this is going to happen. All I did was make everything capital letters, right? So I forgot to do the most fatal thing everybody does. I'm going to change the name to L bracket. Because maybe after enough debates at work, we agree, we're not going to call it an N bracket. We're just going to call it an L bracket because that's what it looks like. Okay? So I went and changed that to an L bracket. When I jump back into Solidworks to open that file, do you think the L bracket's going to automatically pop in, or do you think you might have a small problem? Small, sorry. Small. Let's find out. Even when you deleted the title, the bill, brought it back
No, I
in?
haven't even done that, just in my bottom. I tried to change it, I just kept going back to the Facebook.
We'll look at it on yours.
Yeah, I kept going back into the part and maybe renaming it there, saving it as.
One update. Interesting. It did do that up here. So let's look. Okay, so I'm going to go to File, Open. Here's my assembly. Bingo! You should get an error message. This is it. So you got to browse for that file and find it. Now let's say I cancel that error message. Just watch what happens. It says open summary. 0 dialogues were automatically dismissed. 1 file was suppressed. 0 replaced files were opened. Notice what it did. It put everything it could in here except the item that was missing. And it shows you in here the items that are MIA. So you can click on this, okay? And let's say set to resolve. If we set to resolve, it's going to be like, huh? Where are you finding it? Okay, so I'm going to go browse for the file and find it. Open it, and it fixes itself. Now, let me just refresh. You think it would fix the other one, right? No, it doesn't. You hit the right mouse button and set to resolve this one. There it goes. The first one is fixed, so that the second one you have to resolve it. Don't ask me why. FYI. Okay? I had to do it to both of them. But anytime you change your file name, literally change the name. All I did the first time around was change it from lowercase to uppercase. So it was able to find it. Okay, because the only character variation was the capital letter versus lowercase. But when you literally change the name in this literal format from whatever the name was before to L bracket, what was it called? N bracket or something like that? Changing it from the word N bracket to the word L bracket, then it completely loses it. Doesn't know what to do. And that's okay. That's just reality. It happens to everything. So if you ever go on a website and the link is broken, you'll get that little dinosaur or something will appear. Sorry, that link's broken. Okay? That's what that's about. So be aware of that. So when you do change your file names, anticipate having problems here. If I say don't save and I just exit, and let's say I want to open up the detail drawing, which is this guy, I should get the same error. Bingo. There it is. See that? Because I didn't save the corrections I made. Browse for the file. If I browse for the file in this mode, everything will be fine. It just updates and it even updates the title block. Isn't that beautiful? Not title block. What do you call this thing? The bill of material. Sorry. It's part of the title block. The bill of materials updated. And here you'll have all your components. Okay? The default is display state right there. X head, this guy, all of these are in here. Now if I click on this right mouse button, that's open part in position, add to library, set to lightweight, show hide, parent child, fonts, different things like that about it, but that's about it. If I open the part, opens the part. Okay? And it shows you all the elements about that part. There's the notes. Does it have any notes? Let's find out. Nothing. There's material not specified. Interesting. Does it have any equations? Some do, not this one. There's all the elements. Here's this. Any comments? Tree display, document properties. Let's see if it's got a design table. Yes, let's create one. Let's see what it looks like. That's if I want to create something, but for every little element. Let's say okay, just for fun. And I could literally control everything. Oh, exited out of it. I could have a design table that creates fasteners on its own. That's what that was, but I didn't complete the process correctly. So this one was not made by us. This is McMaster's part. Discard changes. I didn't do anything to it other than open it up to look at it. There you go. Back to here. And that's assembly for you with a detailed drawing of the assembly.